Yeah. Once again, very good afternoon to all of you. So today we are going to solve the questions from equilibrium. Okay, so mainly the lesson equilibrium has two divisions, right? One is chemical equilibrium and the other one is ionic equilibrium. So physical equilibrium is also there, but only the very few basic concepts will be there. There is no such important topics to be covered, but the chemical equilibrium and the ionic equilibrium topics are very important in this lesson. Okay, so the topics that we are going to cover in chemical and ionic equilibrium are here. So in chemical equilibrium, the types and the law of chemical equilibrium is going to be discussed, and the equilibrium constant and Le Chatelet's principle related questions will be solved. And in case of ionic equilibrium, we will discuss about the questions from electrolytes and its types, acid-base theories, buffer solution, and the questions related to solubility product. Okay, so these are the very important points that we are going to cover, and we are going to take the questions from these topics only. Okay, so let's start from the first. Are you all ready to solve the question? So keep a notebook with you and a pen or pencil with you. So try to solve along with me. Okay. So let us start from the first. So here is the first question. And this is a JEE mains question, last year question. And the question says that for the given hypothetical reactions, the equilibrium constants are as follows. So we have three reactions where X giving Y is in equilibrium with Z, and Z is in equilibrium with W. And the equilibrium constant for all three reactions are given as K1, K2, K3. Okay. So the equilibrium constant for the reaction X in equilibrium with W is. So how to approach this? So this is a question from the properties of equilibrium constant topic. Okay. The properties of equilibrium constant topic. So in that property, if you remember, there are three important properties of equilibrium constant. One is, if you reverse the equation, you need to take the reciprocal of the equilibrium constant. Okay. And the second one is, if you are multiplying the equation by some number n, then that has to go to the power. If k is the old equilibrium constant, then that number n has to go to the power for the new equilibrium constant. Okay. And if you are adding two equations or three equations, then you have to take the multiplication of the equilibrium constant. For example, if I have two equations, then I have to take the multiplication of those two equations equilibrium constant to get the new equilibrium constant. Clear? So these are the three properties which you need to know to solve this question. So now you look into the desired equation. The desired equation is X giving W. Now we have to take this equation from the given three equation. For that, what we can do? We can add all the equations. We can add all these three equations. X is in equilibrium with Y, right? And Y is in equilibrium with Z, and Z is in equilibrium with W. So if we add all these three equations, we will, the common terms will get cancelled with each other, right? So Y and Y will get cancelled with each other, and Z will get cancelled with each other. The remaining things are X giving W. So this is the desired equation. So by adding all the three equations, we are getting the desired equation. Okay. So if you are adding all the three equations, then what we have to do? We have to follow this third property. If we are adding the three equations, we have to multiply the equilibrium constant for all the three equations. For the first equation, the equilibrium constant is K1, which is 1. And for second, it is 2. And for third equation, it is 4. Okay, so to get the equilibrium constant for the required equation, which is K dash, what we need to do is we have to multiply K1 into K2 into K3. Okay, so K1 is 1.0 and K2 is 2.0 and K3 is 4.0. All right, so the answer is K dash will be 8.0. So the equilibrium constant for the reaction yes, X giving W is 8. So option B is the correct answer for this question. Clear? Can you all able to understand? If you can able to understand this question, just type yes in the chat box or give me some response in the chat box so that I can understand that you have understood. Okay, so if you're having any doubt also, you can ask your doubt in the chat box. Feel free to ask it. Yes. So, Nandini doesn't have any doubt. What about others? Other school students? Is it clear? Shall we go for the next question? Shall we solve the next question? Say yes or no, students. Yes. All right. Thank you so much. Now let's go for the second question. The ratio Kp by Kc for the reaction is CO plus half O2 giving CO2. So the reaction is with us. We need to find out the ratio. So to solve this question, you need to know the relationship between Kp and Kc. Okay. So the relation is Kp is equal to Kc into RT power delta Ng. So this is the relationship between Kp and Kc. Okay. So now we need to find out Kp divided by Kc. It is equal to RT power delta Ng. Right. So now what we need to do? We need to find out this delta Ng. So delta Ng is the change in the number of moles of gaseous product and reactant. Change in the number of moles of gaseous product and reactant, which is equal to number of moles of gaseous product minus number of moles of gaseous reactant. So this is the formula to find out the delta Ng, right? So now we have to find out the number of moles of product. Whether first you need to check whether all the reactions gaseous phase. Here in the given reaction, all of them are in gaseous phase. So we can go ahead and we have only one product, which is carbon dioxide, and its number of mole is 1. So in place of NP, put 1 minus. And we have two reactants. Carbon monoxide has 1 mole and oxygen is half mole. So 1 plus half is 1.5, right? 1 plus half is 1.5. So 1 minus 1.5 is minus 0.5, which can be written as minus 1 by 2. Minus 1 by 2 is the delta Ng value. Okay. Now what we have to do? We have to substitute in this equation. So if we substitute here in this equation, we will get the Kp by Kc ratio as it will be equal to RT power minus 1 by 2. So in place of delta Ng, substitute minus 1 by 2. So minus 1 by 2 can be written as 1 by root of RT. Right? 1 by root of RT, because 1 by 2 is the root of RT. Minus means it has to go to the denominator. So Kp by Kc is equal to 1 by root RT. So option D is the correct answer. Option D is the correct answer. So can you understand this? Any doubt? Can you able to understand, students? Or you have to just take the relationship between Kp and Kc and find out the delta Ng value and substitute in the place of delta Ng and get the answer. That's it. Okay. Very good. Okay. So Nandini and Pragati don't have any doubt. And I hope for others also it is clear. If you're getting any doubt in between, please put it in the chat box. Okay. Let's go for the Third question. The following reaction occurs in the blast furnace where iron ore is reduced to iron metal. Okay, Fe2O3 reaction with carbon monoxide is giving Fe and carbon dioxide. Using the Le-Chatelet's principle, predict which one of the following will not disturb the equilibrium. According to Le-Chatelet's principle, find out which one will not disturb the equilibrium. So this is a question from the factors affecting the Le-Chatelet's principle. Okay. 5 factors which affects mainly concentration and pressure, volume, addition of inert gas, all these important factors will affect the equilibrium. Okay. So concentration means by the increase of the concentration of reactant or by decrease of the concentration of reactant. And on the other side, if you increase the product concentration or if you decrease the product concentration, the equilibrium will get affected. Okay. So Pragati is saying option C is the correct answer. Okay, let's check. Let's check. Now, we have to find out which will not disturb the equilibrium. So let's go one by one. Addition of carbon dioxide. Carbon dioxide is a product. Okay. So what I'm doing, I'm increasing the concentration of this gaseous product. So automatically the equilibrium will shift towards backward direction. Right? If I'm increasing the product, then it has to go to left hand side to keep them in equilibrium. So this will affect. The second is removal of carbon monoxide. Carbon monoxide is also a gaseous molecule. So if I remove some amount of carbon monoxide, so the reactant amount will get decreased and again the reaction will move towards left hand side. So the removal of reactant will also affect the equilibrium. Then option C is addition of Fe2O3. Fe2O3 is a solid. Okay, Fe2O3 is a solid and here also it is yes only, solid. Okay, Fe2O3 is a solid. Whether you are adding the solid or removing the solid, that doesn't affect the equilibrium. Okay, addition of Fe2O3 which is present in the solid form will not disturb the equilibrium. Okay, so only the gaseous particle and the aqueous particle concentration will affect the equilibrium. The solid and the pure liquid particles will not affect the equilibrium. So option C is the correct answer as Pragati told. Very good, Pragati. Your answer is correct. And the removal of carbon dioxide again will affect the equilibrium or it will disturb the equilibrium because the carbon dioxide is a product, right? If I remove the product, the equilibrium will shift towards right side to keep them in equilibrium. So it will also disturb the equilibrium. Only the third option will not disturb the equilibrium. The answer is because it is a solid. Because it is a solid. Fe2O3 is a solid. Go for the next. Shall we go for the next question? Students, am I audible? Hello? Hello, can you hear me? Yeah. Okay. So the next question is the equilibrium constant for the reaction SO3 giving SO2 and half O2 is Kc, which is equal to 4.9 into 10 power minus 2. The equilibrium constant Kc is so this is the given equation and the Kc for this equation is given and this is the desired equation. Desired equation means the reaction or the equation for which we need to find out the Kc. Okay. we need to find out the Kc for this equation. So what we can do, we have to get this equation from the given equation. So how to get this? So in the given equation, we have sulfur dioxide in the product side. But in the desired equation, we have sulfur dioxide and oxygen, both. Sulfur dioxide and oxygen, both in the reactant. Okay, first you reverse the given equation. If we reverse the given equation, we will get SO2 plus half O2 giving SO3. Okay. Since I have reversed this equation, the new equilibrium constant Kc dash will be the reciprocal of the old equilibrium constant. I told you in the first question itself, right? If you are reversing the equation, you have to take the reciprocal of the equilibrium constant. So that's what I have done. But still we did not get the desired equation. Okay. So in the desired equation, we have 2 molecules of SO2. By the number. So multiply the equation by 2. Okay. If we multiply, we will get 2 SO2 plus 2 by 2 will get cancelled. So 1 O2, which is in equilibrium with 2 SO3. Okay. Since I have multiplied this equation by 2, I have taken 2 to the power, right? So Kc dash will be equal to 1 by Kc power n. And that n is 2. That n is 2 for our case. So what we have to do? We have to find out Kc dash, right? It is equal to 1 by Kc square, which is equal to 1 by Kc value is 4.2 whole square, which is equal to 1 by 24.01 into 10 power minus 4, which is equal to 0.0416 into 10 to the power 4, and this will be equal to 4.416. Okay. So the final answer will be 416. Option B will be the correct answer for this question. Okay. Option B is the correct answer for this question. So the process is easy. Okay. Process is easy. You just need to your time is in the calculation part. Okay, you have to take the square and you have to multiply and you have to divide, right? So in that only you have to spend some of the things are going to be easy. Clear? Shall we go for the next? Shall we go for the next? So all these questions are from JEE Main 2024 I have taken. So let's go for the next. I hope it is clear. Just learn the properties of equilibrium constant, get used to it to solve these equations. Right? Fine. Let me go for the next question. And again, it is from JEE Mains 2024. Sparingly soluble salt Ab2, the equilibrium concentrations of A2 plus ions and B minus ions are given. The solubility product of Ab2 is. So this is a question from ionic equilibrium part from solubility product topic. Solubility product is the last topic of this lesson. Okay. So we are asked to find out that solubility product, which is denoted by the symbol Ksp for this compound Ab2, for the salt Ab2. Okay. So to approach this question, first of all, I need to dissociate this salt. So how does this salt get dissociated? Ab2. So it will be dissociated as A2 plus and 2B minus, right? For any type of salt given to you in the formula ax and by, you need to do x into a power y plus and y into b power x minus. So this is what I have done. And here x is 1 and y is 2. Okay. So 1 into a power 2 plus and 2 into b power 1 minus. So that is why we are getting this equation. Okay. Now what I have to do to find out the solubility product. The solubility, here I have one cation and two anion. One cation and two anion, right? So here KSP. KSP will be equal to the concentration of A2 plus power 1 into concentration of B minus power 2. So that stoichiometric coefficient has to go to constant also, right? So in the same way, you write for this also and substitute the values. The concentrations of these two ions are given in the question. For A2 plus ion, it is 1.2 into 10 to the power minus 4. And for B minus, 0 to into 10 to the power minus 2. You just make common. You make this also as 10 to the power minus 4. Okay. If I make this as 10 to the power minus 4, if I'm making this as 10 to the power minus 4, I have to move the decimal to right hand side. Okay, so that I will get 2.4 into 10 to the power minus 4 square. Clear? So now what I can do, I can, it is 1.2 into 10 to the power minus 4. And if I take into 2.4 will be 5.76 into the power. Okay. So 10 power minus 4 and 10 power minus 8 will be 10 to the power minus 12. And if I multiply these two numbers, I will get 6.912 into 10 to the power minus 12. All right. So option C is coming out to be the correct answer. KSP is 6.912 into 10 to the power minus 12. Clear? So whatever might be the salt, dissociation can be done using this formula and substitute the concentration values and get the answer. That's all. All right. If you don't make this power as 10 to the power minus, need to spend time in doing the calculation because it is 0.24. So it will take, it is a time consuming thing. So that's why I have changed the power from minus 3 to minus 4. All right. Shall we go for the next? Shall we go for the next? This equilibrium lesson is a physical chemistry lesson, right? So we have to do the numericals. There is no other way. For some questions, we don't have to do. Some questions will come from the theory part, but most of the questions are from the numericals part only. So you just need to learn the formula and you have to apply. That's all. The remaining things are with the multiplications and the divisions, additions, subtraction only. Okay. Shall I go for the next question, students? Are you ready? You have understood, right? You guys have understood, no? Yeah. The next is, when the hydrogen ion concentration H plus changes by a factor of 1000, the value of pH of the solution is decreases by 2 units, increases by 2 units, decreases by 3 units, and increases by 1000 units. Which one is the correct option? When the concentration of H plus changes by a factor. So it is changing from one value to 1000. So let me take that one value as 1. Okay. So let me take that initial concentration as 1. Let the initial concentration of H plus be taken as 1. Okay, let me take it. as 1 because this is my assumption. So it means that concentration, the initial concentration of H plus is taken as 1. And by using the pH formula, we know that pH is equal to minus log of H plus concentration, right? So if you substitute the concentration of H plus as 1 in this formula, what you will get? It is minus log of 1. Minus log of 1. Pragati, is it option A? Okay, let's check. Let's check. So it is minus log of 1 and we all know that log 1 is equal to 0. Log 1 is equal to 0. So pH is equal to 0. pH is equal to 0 for the initial concentration. Now what is happening? It is changing by 100 units. It is the concentration is of H plus changes by, sorry, not 100, 1000 units. Right, 1000 units. 1000 means it is 10 to the power 3, right? 1000 means it is 10 to the power 3. So the final concentration of H plus right now is, therefore, final concentration of H plus is 10 to the power 3. Now on applying to this pH formula, what will you get? pH is equal to minus log of 10 to the power 3. So the answer will be minus 3, right? Minus log of 10 to the power 3 is minus 3. So initially I have the pH value as 0 and now after changing by 10 power 3 units, it is getting decreased by 3 units. Okay, 0 is getting converted to minus 3. 0 is getting converted to minus 3. So the answer is it decreases by 3 units. Option C is the correct answer. Option C is the correct answer. Pragati, you are going for A and B. Can you understand now? I hope it is clear now. Is it okay? Shall we go for the next question? Yeah. For the reaction in equilibrium N2 plus N2 giving delta H is equal to minus. The reaction is favored in forward direction by. So 4 options are given to us and they are asking us to find out one, which option will favor the forward direction. Which option will favor the reaction to go towards the forward direction. Okay, the first one is the use of catalyst. Use of catalyst will not affect the equilibrium or it will not shift the equilibrium forward direction or reverse direction. Okay. Catalyst is the substance which will just I'm sorry, my dear students, just wait for some time and I will. So here in our place, there is a cyclone formation. So there is some network issue and that's why this has happened. Can you able to see screen? Can anyone reply? Can anyone reply if you can able to hear my voice and able to see the screen or not? One of you reply me whether I'm audible and screen is visible or not. Nandini or Pragati, just let me know. Prithviraj Patel, Runal, anyone can tell me whether I'm audible and my screen is visible or not. Hello? Yes. Thank you so much, students. So I was saying that this reaction is, the reaction will not be favored in forward direction by the use of catalyst, because the catalyst will affect only the speed of the reaction but not the equilibrium. Okay, so the equilibrium will not shift towards right or left. Then coming to option B, by decreasing the concentration of nitrogen. Nitrogen is the reactant. Nitrogen is the reactant. So if you are decreasing the concentration of the reactant, the amount of components present in the reactant side is getting lowered, right? It is getting decreased. So automatically what will happen? The reaction will move towards backward direction, right? It will move towards backward direction. Now, Nandini is saying option D as the correct answer. Okay, wait. Let's check. Let's check, my dear. Let's check. So, obviously, if you are decreasing the reactant, the equilibrium will move towards backward direction. Then only both of them can be equal, right? So it shift the equilibrium towards backward direction. Now coming to option C. By lowering the pressure and high temperature and high concentration of ammonia. Ammonia is the product. Ammonia is the product. If you increase the concentration of ammonia, more amount of product will be present in the reaction mixture. Okay. So if the product amount is very high compared to the reactant, again what will happen? The equilibrium will move towards left side only. Again it will move towards left side only. Then only both of them can be in equal. So if I'm increasing the concentration of the product, the equilibrium will move to backward direction. Okay. Then coming to option D, by increasing the pressure at high pressure and low temperature and high concentration of H2. High concentration H2. H2 is the reactant. H2 is the reactant. So if I am increasing one of the reactant concentration, automatically the equilibrium will shift towards forward direction. Okay, equilibrium will shift towards forward direction because we have A plus B in equilibrium with C. If I am increasing this, what will happen? The reactant amount is more compared to the product. So automatically it will move towards forward direction. So option D is the correct answer. So if you are increasing the concentration of the reactant, then the equilibrium will move towards forward direction. Okay. And also the delta H is negative, right? Negative means the reaction is exothermic. So for exothermic reaction, increasing the concentration of the reactant will favor the forward reaction. Okay. So I think Nandini answer is correct. Nandini said option D only, right? Very good. Very good, my dear. Your answer is correct. So this is a NEET 2024 question. Your answer is correct. So now let's go for the next question. In which of the following equilibria Kp and Kc are not equal? In which the Kp and Kc are not equal? So this is a very simple and easy question from NEET 2024. Can anyone find out the answer for this question? Can you guys try? You have to use the Kp-Kc relationship for all. That's it. The only job that you have to do is find the value of delta Ng for all the reactions. Try to find out the answer using Kp-Kc relation. Kp is equal to Kc into RT power delta Ng. Okay. So I will do it. If anyone has got the answer in between, you can let me know your answer in the chat box. Okay. So for the first reaction, we need to find out delta Ng. So what is delta Ng? I told you like number of moles of gaseous product minus number of moles of gaseous reactant. So the gaseous products are two products we have. One is PCl3 and the other one is Cl2. So we have 2 moles of product here and 1 mole of the reactant. So 2 minus 1 is equal to 1. So delta Ng value is 1. So what I have to do? I have to substitute 1 in the place of delta Ng. So Kp is equal to Kc power 1. Okay. So now here Kp and Kc are not equal, right? So I will get Kp only if I multiply R and T with Kc. Both of them are not equal because delta Ng is not equal to 0. Only if delta Ng is equal to 0, Kp will be equal to Kc. Okay, keep this in mind. If only if delta Ng is equal to 0, Kp will be equal to Kc. Otherwise, in all other cases, it will not be equal to Kc. In the question also, they are asking to find out the option which is not equal, in which Kp and Kc are not equal, right? So option A is the correct answer for this question. Okay. So I will cross-check with the other options also. Listen. The delta Ng for the second reaction will be, there are 2 moles of gaseous product. So put 2 and we have 2 reactants, 1 mole each. So 1 plus 1 is 2. So 2 minus 2 is 0. If delta Ng is 0, Kp is equal to Kc into RT power 0, right? RT power 0. So anything to the power 0 is equal to 1. So Kp is equal to Kc. Okay. So for the second reaction, it is equal. When delta Ng is equal to 0, Kp is equal to Kc. And for the third also, you can check. We have 2 products with 1 mole each. And 2 will be 0, will be equal to Kc. For the last reaction also, we have 1 mole of products. Delta Ng will be 2 minus, and the reactant is also having 2 moles. So 2 minus 2 is 0. So Kp will be equal to Kc. So is it clear? Is it clear to all of you? If delta Ng is equal to 0, then Kp is equal to Kc. In all other cases, it will not be equal to Kc. So option A is the correct answer for this. All right. Shall I go for the next question? Shall I go for the next question? Yes. Okay, the next question is, Kp for the following reaction is 3 at 1000 Kelvin. So Kp is given. The value 3 is the value of Kp. The temperature is also given as 1000 Kelvin. What will be the value of Kc for the reaction at the same temperature? And R value is also given. Okay. So we are provided with Kp value and temperature value and R value, and we need to find out Kc. So again, use the same relation. Kp is equal to Kc into RT, power delta Ng. Okay. So we need to find out Kc. So Kc is equal to Kp divided by RT power delta Ng, right? So what is the delta Ng value for this reaction? So we have 2 moles of product, gaseous product, and we have 1 mole of gaseous carbon dioxide and 1 mole of carbon in solid form. You should not consider the solid end. You should consider only the gaseous molecule. Okay. So we have to take the value as 1. We take the value as 1, which is for carbon dioxide. So 2 minus 1 is 1. So delta Ng value is equal to 1. Delta Ng value is equal to 1. So just substitute the values of the remaining terms. Kp is 3 divided by RT. R value is 0.083 and the temperature is 1000 Kelvin, right? So this will be equal to 0.036 and this can be written as 3.6 into 10 to the power minus 2. So if you move this to 2 decimal places to right side, you will get 10 power minus 2 with 3.6. So Kc is equal to option C. Okay. So Kp-Kc relation is very important. Okay. Many different types of questions can be asked from this relation. So learn all the cases and how to approach each and every question which comes from this Kp-Kc relation. Okay. So now let's go for the next question. 3O2 is in equilibrium with 2O3. O2 is oxygen and O3 is ozone. Okay. So for the above reaction at 298 Kelvin, Kc is found to be 3 into 10 to the power minus 59. So what is given? Kc value is given. Kc value is given. If the concentration of oxygen at equilibrium is 0.040 molar, what is this? Concentration of O2. Concentration should be written with the square bracket, right? Concentration of O2 is given. Then the concentration of O3 in molar is the unit of concentration. Okay, unit. So now we are provided with O2 concentration and we are asked to find out O3 concentration. So how to approach this? So let me write the reaction first. 3O2 is in equilibrium with 2O3. So if you write the equilibrium constant for this reaction, Kc will be product concentration divided by reactants concentration raised to the stoichiometric coefficient. So it is O3 concentration, which is the product, power 2 divided by the reactant O2 concentration, power 3. Okay. So what we need to do? We need to find out concentration of O3. Concentration of O3 is to be found. So keep O3 concentration one side. So O3 power 2 is equal to Kc into O2 power 3. So it is equal to Kc is 3 into 10 to the power minus 59. It is given in the question into O2 concentration 0.040. 0.40 cube. Clear? So now if you take the cube and multiply, you will get O3 concentration power 2 is equal to 1.9 into 10 to the power minus 63. Okay? Minus 63. All right. But this is the value for O3 power 2. We need to find out only the concentration of O3, not the square value. Got it? So I can write this as 9 into 10 to the power minus 64. I am making this power 63 as 64 for the simplification. Okay. So because if I take the square, I can take the 64 out as 32, right? So that's why I have converted this. Now O3 will be equal to root of 19 into 10 power minus 64. If you take minus 64 out from the root, it is minus 32 into, and the nearest number for 19 is 16. You all know that root 16 is equal to 4, right? So it will be some 4 point something. 4 point. So only one option is having 4.38 value, right? So that is the correct option. Option A is correct. Okay. So option A is the correct answer. So you need to follow some tricks to find out the answer by using this calculation, okay? Like in doing the powers, moving the decimals and in multiplications. So if you solve many questions and if you practice with many questions by doing the calculations, you can get to know and you can solve it very fast. Now I'll go for the next question. Question number 11 of today's session, which is a neat question again. An acidic buffer is prepared by mixing. So after a long time, we have the theory-based question here for you. So can anyone find out the answer? So this is a question from buffer solution. So there are two types of buffer. One is acidic buffer and the other one is basic buffer. And acidic buffer is prepared by mixing. So what is the combination for acidic buffer? Which option is correct? And I will give you one more thing also. Option A and option C. The answer lies in option A or C. Can anyone find out now? If you have
Option A,
studied,
ma'am.
you might have answered me right. I think you guys did not go through the things. But no problem. We are all in the learning process. So you can find out the answer and I will tell you the answer for this question. From
Option A, ma'am.
the question is asked from buffer solution. Please don't think for long time, okay? So acidic buffer is a solution of weak acid and its salt with a strong base. Acidic buffer is prepared by mixing with the strong base. Okay, clear? Acidic buffer is prepared by mixing weak acid. Weak acid means I can take acetic acid and its salt. Its means weak acid salt with a strong base. Okay, weak acid salt means this is the weak acid. And if this weak acid is treated with a strong base like NaOH, they will form a salt, right? By the removal of water, they will produce a salt. So which is CH3, COO, and H2O. Okay. So this is the salt. This is the salt. This is a strong base. Sodium hydroxide is a strong. This is the salt we get from the weak acid and strong base. Okay. So CH3COO is the weak acid salt with strong base and CH3COH is the weak acid. So if this is the acidic buffer mixture, this is the one of the example for acidic buffer mixture. Got it? Now let me. The next question is also from pH. Okay, the pH of the solution containing 50 ml each of 0.10 molar sodium acetate and 0.01 molar acetic acid is. So we have the value of pKa. Okay, we have the value of sodium acetate, which is the conjugate base. And we have the concentration value of acetic acid. Acetic acid is an acid. Okay. And we have the volume. We are asked to find out the pH. So how to find out? pH is equal to pKa plus log of conjugate base, concentration of conjugate base divided by the concentration of acid. Okay. So this is called as Henderson-Hasselbalch equation to find out the pH. Okay. So now you substitute the values. pKa is 4.57 plus log of conjugate base concentration is 0.10 and acid concentration is 0.01. So 0.10 can be written as 10 to the power minus 1 and 0.01 can be written as 10 to the power minus 2, right? So just move the decimal, you will get this. And they'll cancel with each other, and I have 10 to the power minus 1 in the denominator. If it goes to the power, what I will have? Not power. If it goes to the numerator, I will have 10 to the power 1, right? So 4.57 plus log of 10 to the power 1. So we have log 10. Just before few minutes in one of the question, I told like log 10 value is 1. Okay. So what I have? 4.57 plus 1, which is equal to 5.57. So which is the value for the pH. Option A is the correct answer for this question. Okay. Option A is coming out to be the correct answer for this question. So we just need to learn this Henderson-Hasselbalch equation to find out the pH. Got it? Now let me go for one last question for this session. Okay. The question says the pKb of dimethylamine and pKa of acetic acid are 3.27 and 4.77 respectively at temperature. The correct option for the pH of dimethyl ammonium acetate solution is. So we are provided with the pKa and the pKb values. Okay, 3.27 is the pKb value and 4.77 is the pKa value. We need to find out the pH of dimethyl ammonium. Okay, so dimethylamine is the base and acetic acid is the acid. Okay, and this is the acid base containing salt. We need to find out the pH of this salt. So this can be calculated using 7 plus 1 by 2 of pKa minus pKb formula. This is the formula to find out the pH for weak acid and weak base containing salt. Okay, for weak acid and weak base pair. So just substitute the values. 7 plus 1 by 2. pKa is 4.77 minus pKb is 3.27. You should be very careful in substituting. Okay. So the first number 3.27 is for pKb. Okay. The second number is for pKa. If you substitute in the other way around, like in place of pKa, if you substitute 3.27, then you will end up with the wrong answer. Okay. So you will get what is 4.77 minus 3.27. It is 0, 5 and 1. So 1.5, right? 7 plus 1.5 divided by 2. So 1.5 divided by 2 is 0.5. 0.75. 0.75 and 7 plus 0.75 is equal to 7.75. So the pH of this salt is 7.75. Option D is the correct answer. Okay. So students, I hope the session is very useful and clear to all of you. Do you have any doubts from today's questions that we have solved? As we are running out of time, I will stop here. Let me wrap it up the session. So do you guys have any doubt in today's session? I hope that you have got at least some ideas to solve the questions from the chemical equilibrium and the ionic equilibrium part. Okay. So the main thing that you have to do is learn the formulas, try to apply it for the questions. Okay, you will get used to it or you only if you practice more number of questions. Otherwise, each and every question will be the new question to you. Okay, whatever might be the question I ask, it will be looking very new. So you need to solve more number of questions from all the physical chemistry lessons, like in thermodynamics and equilibrium. Okay, so these are the two main physical chemistry lessons you have in class 11. So for both the lessons, you need to solve more number of problems. All right. So there is no doubt. Okay then, Thank you so much for listening the lecture, students. So see you all with the next set of questions from the next chapter. Okay, take care. Thank you.